In this lesson, I'll show you how to use the rational zero theorem. This is part number 1. The rational zero theorem tells us that if r is a rational zero of f at x, then r is of the form plus minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. The question reads, list all possible rational zeros of f at x is equal to 4x to the power of 5 plus 12x to the power of 4 minus x minus 3. I've given this question an easy rating because all we are doing is finding the possible rational zeros, whereas in part 2, I'll show you how to find the actual roots. Let's go ahead and figure this out. The first thing that you want to do is write down the leading coefficient. The leading coefficient here is 4. So our leading coefficient, LC, is equal to 4. And our constant term, the one that doesn't have a variable next to it, doesn't have a variable being multiplied to it, is this negative 3. So our constant is negative 3. Now you have to find out all the factors of 4. What two numbers multiply to 4 and multiply to negative 3? Well, for 4 we have negative 1 times negative 4, 1 times 4, 2 times 2, negative 2 times negative 2. We can summarize that by writing plus minus 1, plus minus 2, and plus minus 4. For the constant, its factors are 1 times negative 3 and negative 1 times 3, which can be summarized as plus minus 1 plus minus 3. Now, according to the rational zero theorem, what we're supposed to do next is divide the possible rational factors for the constant with those of the leading coefficient. So I'll take plus minus 1 and plus minus 3 and divide them by plus minus 1, plus minus 2, and plus minus 4. We have to find out all the possibilities here. Let's begin with this possibility. We have plus minus 1 divided by plus minus 1. You'll end up with plus minus 1. Plus minus 3 divided by plus minus 1 will give you plus minus 3. You'll do the same thing for this, and similarly for the last term. Plus minus 1 over plus minus 2 is plus minus 1 over 2. We also have plus minus 1 over 4. Furthermore, we have plus minus 3 over 2 and plus minus 3 over 4. What you see here are the possible rational zeros that represent the solutions to the equation that we had. And if you actually graphed the equation, you'll notice that one of the zeros, as predicted, remember we said plus minus 3, is in fact minus 3 and 0. And so there you have it. That is how to use the rational zero theorem.